can't spell embedded computing without AI. Well, you know what I mean. Since AI appears all over embedded systems design, it only makes sense that the technology is front and center at Embedded World North America, taking place this September. Good afternoon and welcome to another episode of DevTalk with Rich and Vin, where we talk about embedded stuff and we have a little fun. I'm Rich Nass, and the guy down there who thinks he's better looking than the rest of us is Vin D'Agostino. How you doing, Vin?
I didn't say the rest of us.
Oh, just me.
Just you. Yeah, exactly. Hey, Rich, how's it going?
It's going great. Thank you very much. So interesting topic that we have here today. Normally we sort of segue into our guest, but I'm going to spill the beans right now. And our guest will be in a few minutes, Jason Hallstrom, who serves two roles at FAU. He's the executive director of the Institute of Smarter Cities, Space, and Health. But for our purposes today, he's the conference chair for Embedded World North America. And what we wanted to talk to Jason about was some of the things that are happening with respect to artificial intelligence and how that leads into embedded system design. And I'm sort of on record as saying that we're not pushing hard enough on embedded. It seems like AI is really aimed at the consumer with medical stuff and the data center, and we're getting a little lost on embedded. So that was one of the reasons I wanted to bring Jason in to talk about if he agrees with that and what we're going to do to change that. But something you said, which really struck me, is that Embedded World North America, which is taking place late September in Anaheim. So we're like, was it 90 days out, I guess, something like that?
Yeah, 90 days out.
What we're talking about here and today with respect to AI might be different in 90 days because it's changing so fast. So if you're the conference chair, how the heck do you put together a conference not knowing where AI is going to be in 90 days? So I'll ask you first, Vin, before I ask Jason to comment. Is that true? Well, you said it, so I would assume that you agree with it.
Well, so, like everything else, life is a spectrum, and everything that we have today was built on yesterday.
Hold on. Life is a spectrum. What does that mean?
Well, it's not, I mean, there isn't one thing in time that stays static forever, right? So things are continuously changing, but they're built on the history that got us here today, right? So if you are gearing things in your conference or in a classroom or whatever towards someone understanding how to use AI, they need to know something about how we got here anyway, and the history isn't changing. So that part is going to be relatively stable. How it's viewed today.
Our design community doesn't give a crap all about history. They need to know how to do their jobs.
Well, no, they better know a little bit about history because otherwise they think it's magic, right? If you think about AI in general, it's not 100% true, but almost by definition, AI is about sensor fusion, or let's say information fusion, right? Because AI is about using algorithms to predict something you can't measure directly. If you can measure it directly, measure it and move on. So you are either looking for something hidden in a signal, that's an individual signal, or you're looking at two or three different signals and using the combined information to predict something that you can't measure directly. And if you don't understand,
this is where I disagree with you. It's about making a decision on something that's going to happen in the future. It isn't just about making a static measurement and moving on. It's taking that information and predicting what will happen down the road.
I'm still stuck on you disagreeing with me. You can take an alternate view, but it's really an uphill climb. Yes, some of it's about the future, like if you're doing predictive maintenance, but something is about it's the church of what's happening now. As Flip Wilson used to say, for anyone who's old enough to remember Flip Wilson.
all three of our listeners who are old enough to know Flip Wilson, but go
Yes,
ahead.
yes. I think there are things that you can measure like right now. Like you can say, is something is a belt tension wrong? Is a belt fraying? Is a an impeller on a fan
I can
out of
I
balance?
understand that, but it's about what do you do about that? What is the action that you take based on what you just learned about that belt?
Well, I mean, sometimes the action is to just stop, and that's no different than a thermostat saying, I'm now at
Uh,
temperature, so I'm going to
that's
stop.
not artificial. Just telling it to stop is not AI.
It could be if it saves a life or saves a bearing on a motor failing that's going to cost you thousands of dollars to fix, right? You have a fan blade that got hit by a piece of hail, and suddenly you notice by looking at the currents in the three phases of the motor that the motor system is out of balance. You can say, all right, I'll let them know and I'll just let it run forever, and now they have to replace a bearing in 3 weeks instead. Or you can let them know that here's a problem and we're going to stop unless you tell me to keep going because it's 107 degrees out and you need your air conditioning, in which case it's worth the $1,000 or $2,000 to replace the bearing on your outdoor unit of your air conditioning. I mean, it could certainly be about the future. Like you could decide that you're going to change the speed of something or you're going to
Right.
whatever, but it could also be, here's a condition that's happening right now and I see it in the signature of the current that I'm looking at. Or that. So in embedded, there's really three major areas for AI. You're either doing vision, right? Or you're doing audio voice analysis. Maybe you're looking for a screech to say that a bell is loose, or you're looking for a baby to be crying, or you're taking a voice command, or you are processing streaming data from an individual sensor or a group of
Mm-hmm.
sensors and looking at the combination of those outputs, right? Those are the three major areas of it. So,
On
but
on
why are you talking to me? We actually have a guest.
I was just going to say it's time to well, actually before I bring Jason, I was going to tell you that I actually agree with you on your three-step process. But anyway, let's ask Jason this question. How you doing, Jason?
Hey guys, doing great. Thanks for inviting me to the conversation today.
My pleasure. So you've been listening to all this, and we my idea about that 90 days is pretty far out. What dawned to me, and we'll have to have you back for a second podcast, because as a professor, you got to go way more than 90 days out when you're preparing your curriculum. But we won't talk about that here and now. But hold on to that. Um, are you in agreement with what we're saying? Disagreement? And I know we talked about a lot of things, but why don't we start with the 90 days out part? Are you able to put into perspective what people need to know, or what they will know 90 days from now?
Yeah, Rich, I think that's a really good question. I think it's a really good point. In the words of the immortal Ferris Bueller, life moves pretty fast, right? So the stuff is changing very, very quickly. It's difficult for everyone to keep up with it. I think, in many ways, to sort of come to your point about the difference between organizing a conference and then being a professor, the timescales are quite different. In a lot of ways, organizing the conference is easier because we're asking the community, about 6 months in advance, what do
Mm-hmm.
you want to talk about? So what do you want to talk about? What's of interest? But I will say it's really hard to predict what the community is interested in talking about and what the community is interested in hearing about. So, if we go back in time, and you and I, Rich, we talked about this before when we started talking about back shoot 9 months ago, what we thought the major themes of embedded world would be about. We had embedded intelligence as one of 5 themes. That was the original plan. And when you look at what does the community want to talk about and what do they want to learn about, well, it's embedded intelligence all over the place. So, I mean, I think in many ways for embedded world and conferences in general, you have to listen to what the community wants to talk about. It's awfully hard to predict in this space what it is they're going to want to talk about. And in this case, folks want to talk about AI, and they want to talk about AI up and down the embedded stack in ways that I think we hadn't anticipated.
So let's talk about that a little bit, because my comment was that embedded is someone getting the short straw when it comes to AI, with because so much attention is being put on the data center, and at the other extreme on the consumer side. And I said medical before, and I'll say it again: the advances in medical AI are huge, and embedded seems to it just has always moved slowly. Are you seeing that people are making the same advances in the embedded spaces that they are at the other two ends of the spectrum?
Yeah, I mean, I think you're right. I think it does take longer for these kind of advancements to make their way into the embedded space. And I think that's just the classical problem of resource constraints, right? So what we can do in the cloud, sort of to borrow concepts I've heard elsewhere, what we're going to be able to do with computers that live on our desk or live in the cloud, it's always going to be more than what we can do with the device we carry in our pocket, no matter how powerful that device in our pocket might be. So it does take longer for the things that emerge in data centers to make their way down into the embedded space. But with that said, I think we've seen a real shift from last year's program. So last year, when we looked at where was the AI activity in embedded, it was really all about the edge. And I would say it was fairly siloed, right? So it was about how do you get AI models to run at the edge, and what we meant last year by edge was the base station or the gateway. So the not
You have
really
to tell
down
the
into the.
audience you're doing air quotes.
Oh, I'm doing air quotes for edge. Yeah, for edge and gateway. When we look at where is AI making its way into the embedded space now, for one thing, I think what it means to be edge has changed. So I think now it's much more this, it's fog, right? So folks are interested in AI at the data center. They're interested in how do you integrate AI at the historical edge, which was the gateway or the base station. But now we're seeing a lot of interesting work where folks are moving AI all the way down to the most resource constrained devices in the embedded stack, down to those individual sensors, which is why I really like Vin's example of this kind of fan blade scenario where you have a fan blade that gets struck with, whatever, a piece of debris, and then you start to see bearing failure and trying to figure out how to do some predictive maintenance, right? When are you going to see a failure in that bearing? That's actually an application that we've begun to see. So folks doing on very resource constrained 16-bit micros doing AI for predictive maintenance. I mean, that's something that we weren't thinking about, 4 or 5 years ago. So I think we're really starting to see, I think this is sort of the point where we're going to see AI moving up and down the embedded stack. And by the way, that's not even to bring up how AI is impacting the development cycle, which is a totally different thing, right? So the application of generative AI to firmware development, to PCB design and schematics and silicon design and blah, 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 right? On and on and on. So it's kind of really, I think we're seeing a watershed moment for the embedded community.
Do you make a distinction between AI and machine learning? Because the example that you guys are talking about is a machine learning example, in my opinion. And it's not as advanced and doesn't need the processing that you do to do real full-blown AI. Jason, and I'll let you answer too, then.
Yeah, Rich, I think of machine learning as AI, and I'm going to borrow a very old definition of how I think of AI. So historically, when we talked about what was artificial intelligence, it was the discipline that would eat itself. So the idea was that AI is using a computer to do something that computers could not classically do, that only humans could do, and then it was AI. I think, when we look at say, what's happened over the last 3 to 4 years, when folks talk about artificial intelligence, the vast majority of the world is talking about generative AI. They're talking about LLMs. So, I still think of AI as being that umbrella term for, shoot, I find it hard to describe actually. So as being the umbrella term for all things related to perception, prediction, and generation that are not discrete, right? Or not deterministic rather, which are stochastic.
Ben?
I yeah, I completely agree with that, right? I've always looked at it as when you think about intelligence in humans, it's not about the amount of knowledge
Is
that,
that a
well,
joke?
No, no. Some intelligence,
Vin was using air quotes. I saw him,
if we're,
Rich.
I'm not. I mean, if we talk about artificial intelligence, the other side of that is real intelligence. And where does that come from? Does it come from beavers building dams, or does it come from the way humans are interacting with the world around them? Right. So, when we talk about intelligence, the uninitiated might consider talking about knowledge, but it's really about synthesis, which means you are taking a bunch of things that you know and synthesizing something new from it, right? And so I think of artificial intelligence in the same way. When you look at, let's just take streaming data analysis, because that's a very illustrative viewpoint. You may not know what it is that's going to help you predict something. So you're going to take 120 lines of data and you're going to look at it the same way we used to do reduction of digital circuits with looking and seeing what's a don't care. Like, what doesn't matter? The output doesn't matter whether it's a 0 or a 1. And you're going to do the same thing with this. You're going to say, okay, in the conditions that I've created that I want to be able to detect, of the 125 lines of data I'm taking, only these 3 actually matter. And so now you've done reduction and you say, if I just look at these 3 quantities, I don't need 120 sensors. I need 3 sensors, or I might need 2 sensors and look at the data from one sensor in 2 different ways. And from that, I can predict that something is going to happen. So it's synthesizing a reality that it's not measuring directly. And so that could be done on a very simple 16, or I mean, there are a lot of 16-bit parts out there, but if you're running ARM, you're at 32, right? And everybody at this point has got an ARM part. So and it doesn't matter whether it's a small M0 plus kind of device or whether it's an A9 architecture mixed with 2 other cores or something, right? So, I mean, there's a big, wide gamut of things you can run this stuff on, depending on the amount of computing power you need. And in many cases, you don't even need some specialized hardware to run, certain AI algorithms. A lot of this stuff can run using the DSP extensions on the regular ARM instruction set. So, this is something that's really, for me, about synthesis. And so you can say machine learning is an AI. Okay, all I would say that all AI is not machine learning, but all machine learning is AI, right? It's a subset of what's going on.
Yeah,
Okay.
I agree.
Before I move on to the next subject, I want to bring this back to embedded world. With all the stuff that we just talked about, in what way will this be covered at embedded world, Jason?
Rich, if I have the numbers right in my mind, I think we have 86 technical talks at Embedded World this year. At least 60% of those talks touch upon AI in one way or another. And that's everything, just as we're talking about. So that's everything from perception to prediction, machine learning on very resource constrained 16-bit micros to higher end. I think it's always funny when we talk about embedded systems now, and we talk about something like a DGX Spark, which will be represented at Embedded World. That's an embedded device. It is technically resource constrained, but it has 128 gigs of RAM. So the constraints are quite different than they were, just a couple of years ago. We're going to see AI in the development cycle, everything from generating test cases to, just as I said before, generating silicon to managing the overall production workflow. We're going to see nice talks on how do you when you have these AI modules that are integrated within your product and the product is deployed and those AI models need to be tuned and modified over time, how do you guarantee reliability? How do you manage trust with users? I mean, there are a lot of interesting questions there. So you're going to see all that represented at Embedded World in at least 60% of the talks.
Excellent. When I think of embedded world, and historically, it's always been about the ecosystem and all the different pieces of an embedded system all coming together or the pieces of the design of an embedded system all coming together. In what way will this be represented at Embedded World?
Yeah, I think that's a great point, Rich. And I think, the flavor of embedded world to me remains the same. That embedded world has always been about bringing that full ecosystem together. I think in many ways AI just amplifies that. So when you think about what it means to build not just an AI system, but an AI product, that brings in everything from what are the chips that are needed to implement that product? What are the accelerators that are right for that particular perception or prediction task? How do you manage the models? Are these going to be edge first models, or are they going to be models that we're going to draw from the cloud and we're going to compress and prune to try to squeeze onto the device? We're going to see this represented in the overall workflow. So we're going to see not only on the exhibit floor, we're going to see vendors who have new production pipelines that are all AI first pipelines for deploying and managing firmware and managing the whole life cycle. So we're going to see this up and down. I mean, really up and down the embedded stack, everything from chips to firmware to connectivity to cloud, and then of course everything that lives in the middle. So you're talking then about safety, security, compliance, trust, and so on. So I think AI forces the embedded ecosystem to really come together in ways that we've seen before, but I think are accelerated by the need to deploy these incredibly complex systems that still in some ways I have these black box components, right, that are very, very tricky to reason about and to ensure reliability of.
Let me spin this back to you, Vin. What are the places in embedded design that people have a tough time with, where they should be looking to an event like an embedded world to get more help, whether it's in the classroom or from the vendors on the exhibit floor?
Well, so you're not going to like my answer,
Do
because
I
it's
ever?
not. That's how this podcast got started, right? Well, that and the rival schools, but we won't get into that right now. So,
Well, now we got a third school in the mix.
I know we have a third
How
school
much
in there.
engineering can they learn in Florida, right?
Oh, they can learn some really good engineering.
Wait, now I got to know, what are the schools? What are the other two schools?
I went to Stevens Institute. He went to New Jersey Institute of Technology. So,
Oh, all right, all right.
so we
Hardcore
we
New Jersey.
Hardcore
well,
Jersey.
yeah.
All right, I'm an Ohio
Well,
State guy, so there you
I
go.
was a Connecticut boy down in New Jersey. So
Anyway.
anyway, so the thing that I see I hate to say in my practice, in working with customers, the thing I find the most challenging, or that they find the most challenging, is figuring out how to apply it in a meaningful way, right? It's like you and I have talked about this before. This is not news, right? Um, you and I, Rich, are old enough to remember when radios and TVs were labeled as solid state, because transistors were a new thing and everybody wanted to advertise that they were using transistors instead of tubes. And then it was when, MPUs and MPUs started happening, people were making things that were smart. And then when IoT started happening, people were making things that were connected. So there's this marketing aspect to the technology that, honestly, we as technologists, we may poo-poo it, but it's those kinds of things that have made these things become ubiquitous enough that they have continued to evolve to the point where they're interesting to us and can be used in many places, right? Just think about something as simple as a C compiler. Nobody cared really about C compilers being that optimized. I mean, there was some optimization, but it wasn't until they had to be used. It had to be used to write code for really resource constrained devices, where the compilers and optimizers got so good that if you know what you're doing, you couldn't possibly write, I should say, you wouldn't write assembly code as small or as fast as compiled code, because even if you saw the parallelism, you wouldn't write it that way because it would be unmaintainable. Whereas the C compiler, you can write code, and that didn't happen because something was running on a DEC 10, right? It happened because it was running on 4K of code space and 512 bytes of SRAM. So the application of this, because people wanted to make something smart, is what made the ecosystem around it evolve. And so now we're seeing the same thing with AI, and everybody wants to say they have an AI element to their product, whether it's a graphic design package or whether it's a remote control on the TV or your thermostat, right? So, but people do struggle with, how do I add this cost to my product and create enough customer value that the customer is willing to pay more for the product that has AI in it or has the technology in it, right? This is the core of the business that I run, which is responsibly and appropriately adding technology to a product to increase customer value.
That's the
And
first time we've
honestly,
ever done a plug for your business on
well,
our podcast.
because you interrupted me, because now that we have a professor here, I'd like to say that we don't teach this enough in schools. We are so excited about teaching the technology and the pinnacle, and how to make something happen, that why to make something happen seems to get lost in the sauce, right? And so I think that that's an important part of creating engineers. And as we look at, and you and I have talked about this, we look at AI on the enterprise side, which Jason brought up, right? There's multiple places where AI touches a business. More and more early engineering relevance goes away, because you can use it to do the menial tasks that new college graduates might be doing on the way in. So what do we teach them in school to make them relevant and significant in the workforce? And it's about how to do this well and create value with it, not just do it because you can.
Okay, I think you got a little off topic there, but I certainly get where you're going. So
Well, no,
back
it's
to,
all, I mean, yeah, but it's all about the AI ecosystem, right?
yep.
In the end.
Well, Vin, I think it's a really interesting perspective, and I agree with you. I mean, I think what we're seeing with the use of this word "smart," right, is the same kind of thing, just as you said, with the word "connected" that we saw now maybe 6 or 8 years ago, something like that. I think my favorite example, and Vin, neither you nor I would benefit from this product, but they have a connected hairbrush. And so this connected hairbrush measures the quality of your hair, and it communicates it to an app, and so on and so on and so on. And they have another one, of course, everybody has seen this, the connected toaster and the connected toaster oven, all these things. These strike me as totally insane. I don't see how those create any value for a customer. Maybe I'm biased on the hairbrush, but I guess that's maybe a different story. And I think we're seeing that same kind of thing again, right? I think engineers, maybe by our nature, right? Most of us got into it because we're excited to create. We're excited by the technology, right? I mean, we're
Yeah.
excited by AI modules, we're excited by connectivity, we're excited by all this stuff, even before we understand how it's going to be productized or what value it's going to create for the customer. So I think maybe on your point on training, I think that sort of comes back to the business side, sort of rounding these students out, right? I think if you have folks who are only trained on engineering the technology and look at these amazing technologies that we can produce, then I think all they think about is, how do I shoehorn this AI module into this product, or how do I shoehorn this connected thing into a toothbrush, or whatever. So I think it's important for engineers to have some of that product side experience, either to develop that on the job or to have that as part of their formal training, and have some business education to understand, how do you figure out what the customer really wants, what creates value for the customer, what improves the overall experience. And I think sometimes engineers make it out of these programs and they don't have that background, and then it just becomes, how do I integrate this awesome new widget into the product?
Yeah. By the way, I have an IoT toothbrush.
Come on, man. What are you
I
doing
have an IoT toothbrush with gamification, and my wife makes fun of me all the time. And now, of course, that I've said this, Rich will as well. And I will tell you that my dentist has told me that my teeth are cleaner. And and I've won that, you win badges on the app, and it shows you coverage of your teeth and how long you're brushing, and it pushes things to the cloud and gives you histograms of usage and times of day and all kinds of ridiculous things that I don't look at very often, but it's there. And I will tell you that, and you have to be someone who's into gamification to some extent, right? Like I'll show her, look, I'm at 100%, and she doesn't really care. But my dentist has said, whatever you're doing, keep doing it, because there's much less on your teeth when we're doing our triannual, not semi-annual, 3 times a year cleaning, right? So and so there are ways where you can apply the technology and have it make a difference, right? I will spend another $230 on a toothbrush when I need to replace this one, because I really like the idea that I know that I'm doing a good job.
All right.
So,
this is probably a good place to end. With respect to Embedded World, Jason, when, where, and how do people get more information?
Yeah, so thanks very much again for the conversation today. So Embedded World North America is coming up. It's right around the corner. This is in September. This is going to be in 76 days. So it's right around the corner. For more information, please visit embedded-world-na.com.
And it's in Anaheim, right?
And this is in Anaheim, California this year, September 21st to the 24th.
Very good. That was Jason Hallstrom. He is the conference chair for Embedded World North America. I am Rich Nass, and the guy with the shiny smile down there is Vin D'Agostino. Have a great day, guys.
Thanks, guys.
Thanks, guys.
Thanks, Jason.